Good morning, students. This is your teacher Neela Mehlawat, and I am back with your numericals. See, I was getting a very large number of requests from your side that I should discuss the numericals. Right, everyone? So I am back with the numericals again. So today in this class, I'll be discussing more numericals for you, right? So that there is a concept clarity regarding the numericals. And I hope after this, you will be absolutely clear regarding, you will not have any problem in the solution of the numericals, and the concept will be clear to you. Okay, everyone? So you keep your books and notebooks ready. We'll start with this topic, and it's I think and I expect that your complete focus will be on this video itself. Right, everyone? So let's start with this topic. But as we start with the numericals, let's see. So far we have talked about the human eye. We've talked about the diagram of the human eye, the various components, like what are the various components? The cornea, iris, pupil, isn't it? The aqueous humor, vitreous humor, optic nerve, and where is the image formed? A retina. So these all parts are very, very important from the exam point of view, and their functions also. All various components of the human eye along with their functions. You can be asked to explain the function of any of the components. And then we talked about, in last two videos, we've talked about the defects of the human eye. There are 3 defects, as I hope you remember that. First is myopia. Second is hypermetropia, isn't it? Hypermetropia. And third is presbyopia. So I hope you remember all the 3 defects, and you clearly remember all different types of their corrective measures, like what type of lens we use in myopia. We use concave lens. In case of hypermetropia, we will use the convex lens. In case of presbyopia, we always use, again, convex lens is used, right? And if we have problem like myopia and hypermetropia both, if we have these two together, then we use bifocal lens. Okay, everyone? Right. So let's start with your numericals, starting with the very basic, very simple ones. Question 1. Human eye is more or less like a microscope, telescope, photographic camera, or none of these. Just see, we have talked about it. The human see, it has a lens. It also captures your image, isn't it? So see which one captures the image. The camera captures the image. So your human eye is more or less like a photographic camera. Your eyes also have a lens. The camera also have a lens, isn't it? This lens is made up of glass, but the lens that you have in your eyes is made up of jelly-like substance. So our eyes, they resemble the camera, isn't it? They also click the image, and our eyes also click the image. The nature of lens of the human eye is, think, which type of lens is present in the human eye, dear students? It is always convex. Okay, we have a converging lens in our eyes, and that lens is convex lens. Now, what is the far point of a normal eye? Your eyes are normal. There is no disparity. There is no disease. There is no disorder. So what will be the normal far point? Yes, 25 centimeters is a near point, isn't it? Infinity is the correct answer. Infinity. So the far point is infinity. Now question number 4 says, what is the least distance? What is the least distance, everyone? 25 centimeter. What is it? 25 centimeters. Next, the cells which enable us to distinguish different colors. Just imagine, where are the cells present that help in identifying colors? Yes, everyone, think. Where is image formed? That's the biggest hint I can give you. Where is image formed? Image is formed on retina, right? Image is formed on retina. So cells which help to distinguish different colors. Colors means cone cells. Okay, they are cone shaped cells. The property of eye which used in cinematography. आइज़ की कौन सी प्रॉपर्टी है जो सिनेमाटोग्राफी में यूज़ होती है? आपने मूवीज़ देखी है? हैव यू सीन मूवीज़? सो विच प्रॉपर्टी इज़ यूज्ड? That is called persistence of vision. That is called persistence of vision. Now students, understand this term. What is persistence of vision? देखिए, जब हम किसी चीज़ को देखते हैं, when we look any object which is in front of us, it can be a book, notebook, a person, clothes, right, fan, cooler, anything that we are seeing. So our eyes will create an image on our retina, right? Where they will create? On retina. See, and that image is slightly smaller. That is an inverted image, right? That image is inverted. Okay, so any object that we see, so image will be formed on retina, and that image will be there on the retina for 1/16 of a second. ठीक है, तो जब हम किसी चीज़ को देखते हैं तो इमेज बनती है, और वो इमेज हमारी आँखों पर, रेटिना पर 1/16 ऑफ सेकेंड के लिए रहती है. ठीक है, अगर इससे पहले हम किसी और चीज़ को देख लेते हैं तो 2 इमेजेस बनेंगी. तो हमारा ब्रेन इन 2 इमेजेस को कंटिन्यूस देखेगा. हमारे ब्रेन को ऐसा लगेगा कि ये इमेज कंटिन्यूटी में है. द ब्रेन विल नॉट बी एबल टू डिस्टिंग्विश दीज 2 images, and that is called persistence of vision. So in photography, in cinematography, when we are watching the films are nothing but they are giving you photos. Okay, they are putting the photos before 1/16 of a second. तो हमें ऐसा लगता है कि the people, they are moving, they are talking, they are, isn't it? They are talking and they are slapping, they are fighting everywhere. So our brain assumes that the second picture which is coming is in continuous with the first picture. So what is the persistence of vision? Means our brain cannot distinguish between 2 images if they are projected before 1/16 of a second. That is called persistence of vision. I'm again repeating, dear students, जब हम किसी इमेज को देखते हैं तो जब हम किसी ऑब्जेक्ट को देखते हैं तो उसकी इमेज रेटिना पर बनती है, और वो इमेज 1/16 सेकेंड तक हमारे रेटिना पर मौजूद होती है. इससे पहले हम किसी ऑब्जेक्ट को देख लेते हैं तो उसकी भी इमेज रेटिना पर बनेगी. सो 2 इमेजेस, तो ब्रेन को ऐसा लगेगा कि ये दोनों इमेज कंटिन्यूस हैं, ये दोनों अलग अलग नहीं हैं, ये दोनों इमेज वन आफ्टर दी अनदर है. ठीक है, एंड दैट इज़ कॉल्ड persistence ऑफ विजन. क्लियर एवरीवन? Right. Now let's come to the next question. A little bit complex one, right? A short-sighted person cannot see objects beyond 2 meters. A short-sighted person. Short-sighted means the person is having myopia. The person is having myopia because पास की चीज़ उसको साफ नज़र आती है, दूर की चीज़ नहीं नज़र आएगी. ठीक है? So what is the formula in case of myopia, dear students? Yes, very good. F is equal to minus x. I hope you remember. F is equal to minus x. Okay. I hope you remember this. So what is the x value given here? X is equal to 2 meters. X is equal to 2 meters. So F becomes equal to minus 2 meters. So F is equal to minus 2 meters, right? Now what we are supposed to calculate? We are supposed to calculate the power. Okay everyone? Now what is the formula of power? Just hurry up, tell me. Power is equal to 1 upon F. So F is here. F we know already. F is equal to minus 2 meters. Let's see now. So P is equal to 1 upon F. So that is equal to 1 upon minus 2. Okay, that is equal to minus 2. So P will be equal to minus 0.5 diopter. Why we are writing diopter? Because it is the SI unit of power. So what is the SI unit of power? Diopter. What is the SI unit? Diopter. Right? So the power is minus 0.5 diopter, right? And what is the lens? Since the value is in minus, so this means concave lens. Power is in minus, so the lens we will use is a concave lens. Okay, everyone? Just see it again. The person is having myopia, so the person can see nearby object clearly. So we'll have a problem in seeing the far object. So x given is 2 meters. So our formula is f is equal to minus x. So f is equal to minus 2 meters. So focal length is minus 2 meters. Now p will be equal to, the next formula that we will use is p is equal to 1 upon f. Okay, so p is equal to 1 upon f. So 1 upon minus 2. So p is equal to minus 0.5 diopter. And since the power is in minus, we will use the concave lens. So the lens that is used is concave. I hope you understood, everyone. Yes. So I'll be talking about one more numerical. Let's see this. I hope this also you remember. Are you familiar with this diagram? Yes, in the last video we have discussed it. See, where is the image? See, image is always formed on retina. So in this picture you see retina is indicated by R. So is the image is on retina? No. Where is the image? The image is on P. So image retina से पहले बन रही है. So think of it. All the rays they are coming from parallel. This means they are coming from very far away. राइट सो हमें दूर देखने में प्रॉब्लम है. तो ऐसा कब होता है? लेंस इमेज जो है वो रेटिना पर नहीं, रेटिना से पहले है. सो दिस मीन्स दिस इज़ अ मायोपिया. दिस हैपन्स इन ओनली मायोपिया. ओके, मायोपिया में ही इमेज रेटिना से पहले बनती है. सो कैन यू आइडेंटिफाई द डिफेक्ट? कैन यू आइडेंटिफाई एवरीवन? कैन यू आइडेंटिफाई? Yes, you write it clearly. The defect is myopia. Why it is myopia? Because the person has problem in seeing the far objects. Because the person has problem in seeing far placed objects. Okay, the person is having myopia because the person has problem in seeing the far objects. So myopia में हमें पास की चीज़ साफ दिखती है, हमें दूर की चीज़ क्लियर नज़र नहीं आती है. So this was the question. This was a question which was asked in board 2012. Just imagine, that is why I have taken this question. So you can be given a diagram and you can be asked to explain that particular diagram. Okay, dear students? So this is your homework. I am giving you 7 more questions to practice. Okay, you will solve them in your notebook and you will send your answers to me, and if there is any doubt you will consult with me. Right, everyone? So I'll be waiting for your response, everyone. Okay, bye everyone.